Large language model applications often combine user input, system instructions, retrieved documents, tool outputs, and application logic. That mix creates a trust boundary problem that traditional web application diagrams may not show clearly. Natural language is not just content for the model to summarize. It can also look like instructions. If an attacker can place instructions where the model will read them, the model may follow directions that conflict with the developer's intent. Prompt injection matters because it can influence model behavior, expose sensitive information, produce unsafe outputs, or cause connected tools to act in unintended ways. The business impact depends on what the application allows the model to see and do. This is not magic, and it is not only a model problem. It is a system design problem. Teams need to understand where trusted instructions, untrusted content, model output, tools, data, and user approval meet. Prompt injection occurs when input to an LLM changes the model's behavior or output in an unintended way. The input may come directly from a user, from a web page, from a document, from a retrieved knowledge base, or from another tool. The core issue is that the model receives trusted instructions and untrusted content in the same natural language context. The application may intend one set of instructions, while the model also sees language that tries to redirect, override, or confuse that intended behavior. Unlike traditional injection attacks, prompt injection does not require SQL syntax, shell commands, or a specific programming language. It exploits the way LLM applications interpret language, context, instructions, and authority. Prompt injection should be treated as an application design issue. The model is part of a larger system, and that system must decide what content is trusted, what content is untrusted, what outputs are safe to use, and what actions require stronger controls. Direct prompt injection happens when a user directly enters instructions intended to override or manipulate the application's behavior. The input comes from the user interaction itself. Indirect prompt injection happens when malicious or manipulative instructions are hidden in content the model later processes, such as a web page, email, ticket, document, repository file, or retrieved knowledge base entry. Indirect injection is especially dangerous because the person using the AI system may not see the instruction. The model may treat untrusted external content as valid guidance unless the surrounding application clearly limits how that content can influence behavior. The risk becomes more serious when the LLM can call tools, read sensitive data, send messages, update tickets, inspect repositories, or modify systems. The issue is not only whether the model can be influenced, but what capabilities are reachable after influence occurs. Prompt injection can lead to several kinds of harm. A model might reveal information it should not disclose, ignore application instructions, summarize content incorrectly, produce misleading outputs, or take unsafe actions through connected tools. The risk increases when an LLM application has access to email, files, tickets, cloud systems, databases, code repositories, customer records, or business workflows. In those designs, model behavior can influence real actions or sensitive resources. Teams should distinguish model confusion from system impact. A strange answer may be low impact in a simple chatbot. The same behavior can be high impact if the application passes model output to tools, workflow automation, approvals, or downstream systems. The most important question is not only whether the model can be tricked, it is what the application allows the model to do after it is tricked. Strong system design limits the damage when the model processes hostile or confusing input. Prompt injection should not be treated as a problem that can be solved only by writing a stronger system prompt. Prompt wording can help guide behavior, but it should not be the only security boundary. Defensive design requires layered controls. Applications should separate trusted instructions from untrusted content where possible, restrict tool permissions, require explicit user approval for sensitive actions, validate outputs before downstream use, and limit data exposure. Least privilege matters for agents and tools. The model should not receive broad access just because a workflow is convenient. Tool calls should be scoped, authorized, logged, and designed so mistakes or manipulation do not create unnecessary blast radius. If the model is manipulated, the surrounding application should still prevent unauthorized or dangerous outcomes. That means enforcement belongs in application code, access control systems, validation routines, approval workflows, monitoring, and operational response, not just inside the prompt. Prompt injection defenses should be tested before and after deployment. Testing should be safe, scoped, and defensive with the goal of validating trust boundaries, controls, approvals, monitoring, and data exposure assumptions. Testing may include reviewing how the model handles untrusted documents, verifying tool permissions, checking approval workflows, confirming that sensitive data is not exposed unnecessarily, and ensuring output validation blocks unsafe downstream use. Teams should also monitor production behavior, review incidents and near misses, update threat models, and improve controls as new patterns emerge. Prompt injection risk changes as prompts, models, tools, retrieval sources, data, and user workflows change. Prompt injection is not a one-time checklist item. It is an ongoing AI application security concern that requires design, testing, monitoring, response, and continuous improvement. Prompt injection is a major LLM application security risk where user-controlled or external input alters model behavior in unintended ways. It can be direct, where a user enters manipulative instructions, or indirect, where external content influences the model later. The greatest risks occur when LLMs can access sensitive data or trigger actions through tools. Defenses should not rely on prompting alone. Stronger approaches include trust boundary design, least privilege, restricted tools, user approval for sensitive actions, output validation, logging, monitoring, and ongoing testing.